In the fifth section, we'll be implementing the domain and services in our core project. In this section, we are going to take a look at creating domain models, implementing the repositories, defining and implementing application services, dealing with data transfer objects, and finally handling DTOs with Automapper library. In this video, we are going to take a look at creating domain models. I will briefly talk about what is a domain-driven design, in short DDD, and entities, and then we'll proceed into creating our domain models. Domain-driven design is a really vast technique or a practice or a pattern, and it was basically described by Eric Evans, and there is this like a legendary blue book. And like I said, DDD is a really vast topic, but we can use some parts of DDD into our system, like parts like, for example, domain models, or so-called ubiquitous language or repositories, and so on. Therefore, in this video, we'll actually implement our domain models using good pattern, or actually good practice, which is called the domain modeling. It means that we'll actually create classes here in our core project that will be a rich C# classes, which means that they will have properties with proper setters like protected setters and the methods, and thanks to these methods our domain models will be able to actually interact with each other and work on their internal state, manage their internal state on their own, and so on. So we'll just focus on creating so-called rich domain models. Let's start with creating a new folder here. I will call it a domain. So here I can just click a new folder, domain, and at first we'll create our item, because our application called Kubo will allow to actually create a bucket, and each bucket will have one or more items. So let's call it an item, and let's actually add a new property. So at first it can be of type GUID, and we'll have our internal ID like this. And let's add a new property. So that would be a key, also protected setter here. And here we can also think of adding a new property and just call it a value. So here we can have a value. And finally the constructor. At first we want to have a protected constructor, and I'm going to include this protected constructor mostly because once you start working with some databases or some other libraries that are responsible for serializing your objects, they usually require to have at least a protected constructor in order to properly construct your object instance, mainly by using the reflection mechanism. So we'll leave this protected constructor here, and let's create a public constructor. So our public constructor will actually accept two arguments, our key and a value. We could think of actually doing some validation here, but that's not really required for this simple example, so I just call it key. And we want to ensure that our key is in lowercase, so we just call toLower invariant and actually assign our value. Now let's do something more interesting and implement our bucket. So I'll just create a new bucket class. And our bucket class will be similar to this one in terms that it will also have its own ID. It will have a name. We can also store here a datetime of when was this bucket created. So let's just call this datetime created at, like this. And then we need to actually store our items collection. Of course, we could do it like this. Let's say iCollection of item named items. However, this isn't really a good idea. Why? Because think about for a while. Do you really want to allow the user of this bucket class and user of this class to actually do whatever he chooses with your collection, which means adding, updating, removing items without any internal validation? It's not really the best practice, which means that we should only expose a sort of read-only property for example the IEnumerable interface, and manage this collection on our own. So let's do here a private field like private iSet of item named items, and then we can actually create our own methods to work with this connection, and our bucket entity will be responsible for keeping its internal state properly, which also means that anything that is related to creating or removing items should be fully managed by this class, not by someone else. So let's create our constructor. We'll have one protected constructor here and one public constructor, similarly to our item class. So let's do it like this. And our constructor will accept the ID and the name of our bucket. So let's assign ID and a name here. And now let's create the methods for removing and adding items. But at first, let's create a method to actually getting an item. So let's create a new item, get item or fail. And this one will actually try to fetch the item by key. And if it's not found, it can throw an exception. So at first, let's set our fixed key to lower invariant, like this. And then let's try to fetch our item. So we can call items.singleOrDefault, add a using to link here. And we want to get an item which has a name equals to our fixed key. And then if item is null, we can throw an exception here. So let's just say that item with a name, or actually with a key, was not found in a bucket in our bucket name. And if it was found, then just return an item here. Okay. So here let's add two new methods for creating and removing items. So let's call the add item. It will accept the key and value of our item. So at first, this one will actually try to grab our item. And if it exists, then it will return an error. So let's do it like this. If items any, where the item key equals to fixed key, then we can throw an exception here, which means that our item name is not unique. So let's say item already exists in a bucket. Otherwise, we can add a new item. So let's go items, add new item with our key and a value. And let's create a new method for removing an item. So let's call it remove item, pass our key. And once again, we can actually just make use of this get item or fail. So let's say get item or fail for our key. And if item is found, then we can just call items remove. Alright, and as you can see, both our bucket and item have this ID property. So we can think of extracting some base class. Let's call it an entity. And our base class will have only this ID property, like this. It will be an abstract class. Let's call this protected constructor here. And this one will only initialize our ID and set it to a new GUID. And now our bucket and item can actually derive from this class. Like this, remove this one, and our item here, like this. And actually, if we were talking about the domain design here, this will be our entities, because we can think of these two classes, item and bucket, as classes that require their own unique key. That could be ID or the key string or a name string here. But actually our bucket class will be called something which is named aggregate root, like this. And aggregate root can actually contains other entities. So as you can see, our bucket contains items collection, because our item has no sense on its own. I mean, our item class should only exist if there is a bucket to which it belongs. Otherwise, our item makes no sense to actually exist on its own, which means that our bucket is a root, And our item, even though it's an entity, because it had some unique identifier, it can only exist within our bucket. And this is how our domain models can look like. In this video, you saw what a domain-driven design is or can be, and how we can actually implement domain models in our application.